Hey everyone, welcome back to my channel. Today we are going to solve a medium question on lead code, which is minimum operations to make binary array elements equals to 1. Uh, Before we are going to solve this problem, there is an hard equivalent problem to this. First, let's read the problem statement and I will talk about the other version of this problem. So you're given a binary array, which means the array only contains either 0 or 1. Okay. You can do the following operation on the array any number of times, possibly 0. The operation defined as choose any three consecutive elements from the array and flip all of them. So here, if we take these three elements, consecutive element, if we flip the array, it will become 1, 0, 0. That is one operation. So return the minimum number of operations required to make all elements in nums equals to 1. If it is impossible, return -1. Got it. Okay. Uh, so uh, since I was talking of other version of this problem is instead of three consecutive elements, what if we need to flip k consecutive element instead of k equals to 3, whatever the value. Right. So so you can get this problem from here, which is this question. If we are able to solve for k, like any k, not only k is equals to 3, we can solve it for any k, which is a hard version of this problem. So basically, uh, whenever we see a 0, we try to flip all the k elements, which is all the three consecutive elements, and we'll keep moving. And likewise, if at any position we see a 0 and there were insufficient k elements on the right, then we can return a -1, which is a no. If it is k is equals to 3, we can do it in a linear time by checking three elements, right? Uh, so let me try to code this up quickly. Uh, Maybe we'll start from here, third element. Instead of 3, I've written here. So 0, 1, 2. Since this is a zero based, if this is equals to 0, we need to make a flip, right? So we will count the flips here. And we can do this one. For now, let's get rid of this k. We simply do, since this is a zero based, we need to get the first element. We do 0 minus 2, right? And this will be 2, and this will be 1, and this will be I. So we need to flip this bit. How we can do it is, uh, we can use an XOR operator. It's like if 1 XOR 1, it will be 0. And if 0 XOR 1, it will be 1, which is what we wanted. If it is 1, we need a 0 as output. If it is 0, we need a output as 1. So we'll do the same thing. XOR, XOR, XOR. We can simply do something like this one. And we'll keep doing this one. And at the end, if nums dot size minus 1 is equals to 0, or nums dot size minus 2 is equals to 0, we will have to return minus 1. We will declare a variable. Yeah. So we are checking the first, like we are taking a window of k, which is 3, and we are doing k minus start of the window. We are checking if it is 0, we directly keep 1, and we are flipping the other two elements. If it is 0, we'll make it to 1. If it is 1, we'll make it to 0. So I've explained about the XOR operation. Now, since we process all the elements, we have to check the last two elements. Because we are only considering the start of the window, we'll making it as 0. So if the last two elements cannot be, if it is not equals to 0, then we can directly return the flips that we have made. Let's try to submit it. It got accepted, and the time and space complexity for this solution is big of n, and space complexity is big of 1. This will work because here we are using k is equal to 3, we are doing 3 times. But if it is k is not a constant, how we can do it? We need to keep track of the start of the win like in each window, we have to get the last one, whether it has flipped or not. How we can get that? We maintain a window of size k, and whenever we are flipping it, we'll just mark that as flipped. Like if it is a 0, we mark it as flip, and and so let's say in a given window, uh, we have marked some element, like we have flipped some of the element because we might encounter 0. And let's say the current element, if it can be 1 or 0, right? So we made some flips before, and based on the previous flips, how we can check we can make a flip or not. What I was trying to say is, just think of we made even flips and current number is 0, let's say, and we made odd and current number is 1. Let's say we made even number of flips and either uh, see the transition of, let's say if the element is 0 and we made a flip of 0 which will be 1, and if we made another flip which will be 0, and if we made a flip of 0 it will be 1. So for odd, this is odd positions. One flip, second flip, and this is the third flip, right? Let me call this as 2, 3. So for every odd position, the outcome is always a 1 if it is 0. So consider the even flip, it will come back to its original position. For every even flip, if we make one more flip, flip 4, uh, it will become 0 if we see the outcome. All right. So uh, the number of flips so far we made is even and current number is 0. For sure, we have to make a flip for this element because if we have to make the array all ones, right? This is one observation. And let's say I'll copy it. If the initial bit is 1, this will interchange. If the initial flip is 1, in the first flip it will be 0. In the second flip it will be 1. In the third flip it will be 0. In the fourth flip it will be 1. So in the odd flips, if the current element is 1, we need to, since we have made odd flips, this will be big, this will turn to 0. So we need one more flip to make it 1. Uh, are you getting, let's say if I made one flip so far, and the current element will now turn to be, since it belongs to the window, so it will become 0. So we have to make it as 1. So that's why these are the two observations. Uh, so in the code, what we can do is, uh, let's say for every window, we have to keep track of last element, the start of the window, what is the, whether we made a flip or not at that position. We have to keep track of that. All right. So let's define, um, we can use double-ended queue, which is deck. We will be inserting at the right side and we will be removing elements on the other side, which is left side. Like we are inserting at the end and removing at the front. front. So maybe we'll use linked list, which will be good for this one. Um, um, if window dot size is greater than greater than equals k, and get first is equals to 1, which means that we made a flip. We have to undo the flip. Uh, we can do something like flip off. Uh, we can directly do this one actually. If the last window is, we represent flip as 1. If it doesn't flip, we represent as 0. So one example, it will undo that operation. Uh, so uh, so we are maintaining it as 0 or 1 for these flips. Whether like it is even flip or odd flip, like 0 or 1. And as I explained here, it is a even flip and current number is 0, so 0 equals to 0. This will be executed. If it is 1 and current number is 1, so it will satisfy these conditions basically. Now we will have another variable total flips instead of all this. Excuse me. Total flips, and we'll have to do a flip. Uh, we will add a flip here, and we will add it to the window. Okay. So k is equals to 3 and size. And one more thing here, if I plus k is greater than the size, like since this element needs to be flipped, and so since we are making a flip here, and we cannot have k elements on the right, like k minus 1 elements on the right, we cannot do that flip. So that's why we return minus 1. So let me try to run this one. Okay, it's failing. So let me run. Okay, this should start from 0. For every element, if window dot size is equals to k. Uh, Here we'll have to remove once the window uh, size exceeds. Yeah, what else we can do? We have added we have added k elements. Now we remove the last one and else window dot and last of shift 0 since we are not making any flips. Mhm. Nums of is equals to nums of I plus k is greater than size total flips and flips window dot add last flips. Let me try to debug the solution. So why it is -1. We are for each element. If it is size not equals to k, we are not doing anything. Flips is initially 0. Terms of I is 0, so it will come here, and I 0 plus k, which is 3, greater than size, where size is 9. Else we are making a flip here, and flip of 1, and we are adding into the window. And now we can, which is not equal to 1, 1, so the flip is equals to 1 here. And 7 is equals to 1. So it needs to be flipped. We made a flip. And making a flip here, we mark it as 1 and we will store what is it even flip or odd flip we are doing to toggling the bits. Toggle. Let's try to submit this one. Okay, it got accepted. I'll just copy paste this entire thing and we'll try to solve this one. We'll try to paste here and we'll just remove the K. This is a hard problem, by the way. So we'll try to run it. So it will work for any K. This is an hard version of the today's lead code question. So we can even solve without extra space by marking the start of the window with some variable every time, and that's how we can do it. But anyway, we are modifying the input array, which is not that recommended. So here the time will be big of n and space will be big of k. This cannot be uh, greater than k. I'll just try to do one modification. Window dot size is equals to k. Yeah, I think this is even correct. We missed this part. Like I'm just adding this flip instead of one. Uh, that is it for today, guys. Please, if you like this, if you like my solution and these problems, the two problems you can solve with this approach, you can solve the hard version of this problem as well. And thank you for watching. And please like, share, and subscribe to my YouTube channel. And see you next time. Bye.